Hello guys, I just wanted to spend a moment to review the things that we have done. This week you're going to be finding the resistance total online, the law for that. We have already found the laws for voltage and current. We said that in series VT equals V1 plus V2 plus V3, etc. So that's saying that if we have a circuit set up here, we have a power supply. Remember, we're going from our negative to our first light, from our first light to our second light, from our second light to our third light, from our third light to our fourth light, and then we return back to our, from our last light, our fourth light, we return all the way back to our positive side of our power supply. And so now we notice, and I'll dim the lights here, you can see that all four lights, I'll turn them all off actually, all four lights are lit, right? So I'm going to turn this back on again so we can see everything. So now if I take my meter, and right now I'm using a voltmeter, a multimeter, does voltage, current, and resistance. Has a few other items on here also, but voltage, current, resistance are the ones that we're going to talk about. If you look here, there's two different voltage ones. One has a voltage with a straight line and a dashed line below it, and the other voltage one has that sine wave on it. The sine wave for voltage and current here, amps, means that they're dealing with alternating current, positive, negative, whereas the straight line deals with direct current. We're working with a battery of direct current, 6 volts. So we're going to be on our voltage DC, and I'll turn that on. And I'll set that in a spot here where you can see it. Hopefully you can read that. Maybe I'll lay it flat. Is that easier to read? Yeah, okay. So voltage, millivolts things, so it's just reading some phantom voltage there. If I set this across my power supply, so my negative is right here and my positive is over here. If I set them across that, remember now, we do have to deal with polarity. We have positive and negative direction here. We have 5.53 volts, you can see on the multimeter, voltmeter. If I switch that around, in class, our meter would go to the left of 0, and here, it's still going to read 5.53 volts, but you'll see that it has a negative sign in front of that, and that tells us that our polarity is reversed and we're reading it the wrong way. Nice thing about the multimeter is that it will still read what we want, even though we've made an error in our polarity. Anyhow, so we have 5.53, and if we look at what we said about voltage, where voltage total is going to equal all the individual voltages added up, then we'll go through the line here, and for V of L1, we have 1.45. Hopefully you're able to read that on the multimeter. 1.45. The next one, we have, I'm sorry, I have it backwards here. Still would read it though, as I showed you. 1.27. 1.19. And finally, 1.43. If we add those all up, we'll get very close to our number of 5.553 that we had for our total voltage. So adding each individual voltage drop, the drop that's across this, the difference of potential for each one of these, the negative, positive, the difference in the positive and negative there is how much is dropped across these. And our total voltage is dropped across each one of these when it's in series so that it's divided up evenly, okay? Or as evenly as the resistances allow us. In this case, we have all the same bulbs, so they should have all the same resistance, kind of, sort of, depending on the fatigue of the filament in the bulb. So the numbers are very similar, okay? So that was voltage. We just took our voltmeter and we put it across the item that is drawing the current, or drawing the voltage, or using the voltage, the push, to get through these. So I'm just easily doing this with a meter to the side there. That was voltage. Current, recall, is the flow of electricity along a path, which we're going to call a circuit in here. And there was a difference when we measured current, where we can't just have a live working circuit here that we just go ahead and put our voltmeter up across here and get a number. This time we actually have to be inside the circuit as part of the circuit. So I'm going to change us to amps, and we'll read for this now. So if I want to measure the current between L1 and L2, then I need to remove that part of the circuit. And I'm going to replace that part of the circuit with an ammeter. So here I'm measuring 196 milliamps. Okay? Remember though, eventually we're going to have to change everything into full amps to be able to use it in Ohm's law. But right now we had 193 milliamps, which is 0.193 amps. That conversion, milli, tenths, hundredths, thousandths in the decimal places. Milli, thousandths is the third one over, so we move our decimal place 3 places, as we did in class. So I just measured it in that location, and now I'll take my jumper wire, and I'll put that back to complete the circuit again. So now we have our bulbs on again. If I want to measure between L2 and L3, I remove that part of the circuit, and I replace it with my ammeter. Again, negative, positive, polarity does matter here. You see the bulbs, when I complete the circuit with my ammeter, the bulbs turn back on again. I'll turn off my lights again so you can see that that's happening. So when my ammeter comes on there, I am completing the circuit with my ammeter. Okay? So we measure this one here, and 196 milliamps, almost identical to what we had in the first one. Now I'll replace that part of the circuit again. And we'll come down here between L3 and L4. And I'll remove that part of the circuit. So we have 197.6 milliamps, 194. So it's the same thing. So we said that IT, I1 is going to be equal to I2 is going to be equal to I3, etc. So in a series circuit, your current is going to be the same throughout here because it's got one path to travel on, so they don't diverge ever, the current, to break up. It's all on the same path, so we have the same current. The amount of force used to get through each one of these resistances is different and will add up to the entire voltage used or put across the circuit, but the current is going to remain the same. So IT is the same for all of these. So this information right here, I would like you to have in your notes somewhere. Voltage. Unequal charges produce difference of potential or electromotive force, a force that moves electrons from their valence shells. V or E are the symbols and it is measured in volts. Current is the flow of electrons along a path called a circuit. The symbol is I, and it's measured in amperes, amps, or milliamperes, or milliamps. Polarity, which is where we have our negative and positive correctly hooked up in this circuit here, is the observance of the charge's direction. So we're always going from negative to positive in our DC circuits here. We also have two laws now. Voltage total equals V1 plus V2 plus V3, etc. Current total is the same throughout in a series circuit. Okay? The next one that I'm asking you guys to give me the law for would be resistance total in a series circuit. Remember, we are in a series circuit when you're looking for that answer. It's not in a parallel circuit. Okay? We are going to go through and do the next lab then. I will have that for you Sunday, that video, and you will respond on that and tell me the notes that you've created.